Now let us continue to the topic superposition of waves. Hence, from the basics of superposition of waves, we will go to concept of interference. What do you mean by superposition of waves? When two waves having net displacement, if we consider two waves having net displacement y1 and y2, where one wave is having an amplitude A and it's a periodic function of sine omega t, another is having the same amplitude but differs in phase by an angle phi. Then by superposition principle, as we all know, the net displacement of the two interfering waves is a vector sum of their individual displacements. This will yield to y is equal to a sin omega t plus a sin omega t plus phi. And if we take out a common, then it is sin omega t plus sin omega t plus phi. This I will consider it as sin b, this I will consider it as sin a. So using the trigonometric identity, finally we end up getting 2a cos phi by 2 into sin omega t plus phi by 2. Finally, this term is independent of angular velocity of the wave, instant of time. Hence, if the phase difference between the two waves is a constant, then this term 2a cos phi by 2 is a constant. This we call as a amplitude of the resultant wave. We call 2a cos phi by 2 is equal to r, that is amplitude of resultant wave, amplitude of resultant wave. So initially for individual waves, intensity I naught, that is initial intensity of the light wave, that is proportional to a square, amplitude square, because the two waves have the same amplitude, so their initial intensity is I naught. Now, after superposition, or when two waves meet up, that is called interference, what happens? R square is equal to 4a square cos square phi by 2. This is obviously intensity of the resultant wave is proportional to r square. So this is intensity of the resultant wave. Final intensity of the resultant wave is equal to 4 I naught cos square phi by 2. That is intensity of the resultant wave or the mixture of two individual waves which are mixed with one another with respect to the original intensity is given by the formula 4 cos square phi by 2. 4 cos square phi by 2. So now the intensity final is proportional to, if the individual initial intensities are constant, then the final intensity is always proportional to cos square phi by 2, where phi can determine how the light intensity is going to distribute. So as far as solving the problems are concerned, these three are very important relations. Continuing on, Two, what is interference? We have seen in superposition principle that the net displacement of a resultant wave is a vector sum of displacements of the individual waves. Thereby they interfere and gives you the redistribution in their intensity. Intensity of the resultant wave depends on square of the amplitude of the resultant wave, and whereas the initial intensity obviously depends upon the initial amplitude square of the wave. Now, what is different between interference and superposition? Superposition is general form. There can be any number of waves which are interfering or superposing on one another. Interference of light is a particular form of superposition. What particular? See, there should be only two light waves superposing each other, and they should be from the coherent source. So the question arises, what is a coherent source of light? This is a question that will arise. So coherent source means the two light sources having same frequency of light and ideally in phase with one another. Ideally in phase with one another, or two light waves having constant phase difference, with one another throughout the propagation. This is the meaning of coherent source of light. So, suppose there are two sources, they start like this, At the time, see, at the time this is maximum, this is also maximum. Here, okay, if I redraw the diagram, restructure it, just a little correction. See, at the time it is reaching the maximum value, this is also reaching the maximum value. At the time when it is reaching the minimum value, this is reaching the minimum value. So they are in phase. In phase means their phase difference is 0 degree. So this is light source 1, this is light source 2. And they are having the same frequency. After, see, this completes one cycle, it completes one cycle. So their time period is also same. So frequency is inverse of time period. So they both have, both the waves have same frequency and their phase difference is 0, ideal case. Such sources of light are called coherent. So for the interference of the light to be formed, and there will be redistribution of the light energy or intensity if two light waves from coherent sources means they must be from the light sources which are of the same frequency, and ideally they should have 0 phase difference. And practical case is also possible if there is source 1 like this, and then there is source 2 where there is a constant phase difference. There is a constant phase difference like this. So you can see this reaches a maximum here, this reaches a maximum here. The phase difference is phi. Even if the constant phase difference is maintained throughout the journey, that is also fine, but they should have the same frequency. Even here the sources are coherent. Ideally this must be the case where the phase difference between the two waves is also 0, means you will get lot of bright patches, or redistribution of the light energy will be more specific. That is what we call interference of light. There are two types. One is constructive interference, another is destructive interference. So when the intensity adds up, intensity adding up, it is called intensity adds up in this case. This is called constructive interference. When intensity is destroyed or becomes zero finally, then such a case in which two light waves destroy each other's intensity is called destructive interference. So now we shall look into conditions of interference, conditions for constructive interference. Conditions for constructive interference. So what is a condition for constructive interference we have to see. Now here if you observe, R is equal to 2a cos phi by 2, cos phi by 2. When cos is maximum, resultant intensity is maximum. With the increase in argument of the function, cos value decreases. Then resultant intensity will be minimum, because intensity is directly proportional to resultant amplitude. When phi is equal to 0, ideally no phase difference between two waves, that is they are in phase, R is equal to 2a, because cos 0 is 1. This can take place again when that is 2 pi, then it is minus 1. So cos 2 pi by 2, that is cos pi it will become. When I substitute phi is equal to 2 pi, that is minus 1. Still it is a maximum value, but from the opposite end. 3 pi by 2 if I do, that will be ideally 0. So it should be 4 pi, 6 pi, so on it should be. In those cases, resultant amplitude will be 2a plus or minus 2a depending on the cos value.